Good morning, everyone. Welcome to CES. We're going to be just as fresh on Friday as we feel right now, right? We're going to have the energy going. This is going to be a very interesting discussion. We're going to hit a bunch of topics very quickly. A little bit about myself. I'm an independent consultant in the autonomy space, and I'm one of the old dinosaur types. Been in it since about 30 years, and I work quite in depth with the truck side of it. I think truck automation has so much potential for the whole society as well as for technology and business. With that, we'll do some quick introductions, and I'll hand it over to.
So my name is Sarush. I'm the co-founder and CEO of Aeva. We are bringing next generation perception technologies, specifically coherent, or what we call FMCW, into the market for automation for vehicle, starting with commercial vehicles, passenger, and other applications.
Good morning, everybody, and happy 2025 to everyone. My name is Joanna Butler. I lead the Autonomous Technology Group for Daimler Truck globally. In that role, we're responsible to build this awesome autonomous ready vehicle platform and work with great partners just like Torc and Aeva, and excited for this discussion today.
And last but not least, my name is Peter Schmidt, CEO of Torc Robotics.
We did confirm just ahead of the session that the truck that's here is a Daimler Truck, which made Joanna very happy. And I think it's the coolest part of the whole thing with wrap and everything. You guys did a great job. Peter, can you give us a really quick flavor of what these unusual looking objects are all around the truck?
Oh, yeah. I mean, the core piece, this eyebrow that you see up there, they are all long-range sensing sensors. Radar cameras, and of course the lidar from Aeva that enables us to run 65 miles per hour on that truck. But there are sensors all over the place. So it's packed with sensors from the rubber to the roof, fully integrated. Production intent looks cool, and inside is the brain, a massive computer.
And from what I've heard from your recent releases, Joanna or Peter, that this is production intent. So, Joanna, say a little bit more about that because of your partnership with Torc.
Yeah, so production intent for us really means that we're designing this platform for mass production. So this is not a one-off build. I would say you can do a demo fairly quickly, build one truck, hand build it. But these trucks are going to be built to scale up to tens of thousands of trucks, as we believe that this is the potential of this technology. And it really starts from the ground up, how you design the systems. The vehicle platform is equipped with redundant backup systems. So since you don't have a driver anymore in the cab, you need technology that backs you up if safety systems like brakes or steering fail. So there's always a secondary system that can take over. And then the other big part is how do we integrate this into the production line? So when we design it, we also look at production-oriented design, which means how can the workers on the line install it within takt time, because we need to get those trucks out in 4 minutes. So that's our takt time in our high volume plant, for example. How do we design these components so technicians later on in the field can easily service and maintain them? These are all considerations you have to take in from the beginning. So when you're ready to launch, you're actually ready to scale up and fulfill all the orders for our customers.
Yeah, and anyone who's been in a company flying to an automotive manufacturer, truck manufacturer, knows the challenge of moving into all of those criteria. So, Sarush, what's it like for you with Aeva partnering up with Torc, and what are the challenges, guys, or the hurdles you must pass?
Of course, yeah. I think this partnership for us has been really a perfect partnership. I think we have had the opportunity to work with not only one of the top world leaders in commercial scale, talking about hundreds of thousands of vehicles per year shipped globally by Daimler Truck, but also a company that is super focused, capable in Torc and Peter's team in software as well as integration of new technologies. And together, we're really bringing forward this technology for autonomous driving at highway speeds. For us, we've gone through significant, I think, maturization and industrialization as a company to bringing this technology forward. There is significant standards that we're walking through with Daimler on making sure the product is going to be up to par for automotive and commercial vehicles. goes above and beyond passenger vehicles. So for us, as a first production program, has really helped us to get to the level that we need to bring this technology to market. I think Aeva at this point is, I would say the leading company in bringing 4D technology to market. So I think having that level of collaboration on a day-to-day basis across teams is super important. It's not just the three of us sitting here. Across the teams, have super close collaboration across the efforts to make this happen. And the past year has been a key test.
For those of us who've been around the industry for a while, there's been various incorrect rumors floating around about Lidar, but it's incredibly expensive. That number of $80,000 for Lidar still gets, I see it in news articles. It drives me crazy. And I think we mostly know that that's not the case, but I'll leave it to you guys to sort of respond to that. What's kind of feeling can you give us for both the robustness, because Lidars have been called, maybe flaky or finicky. What's the robustness? What's the general cost aspect?
Sure. I think that's the beauty of the approach we're taking. We've invested at this point hundreds of millions of dollars into not just making a technology happen that is very different than typical time of flight technology. We coined the term 4D LiDAR. And if you walk around here, there's now some others started to talk about that, but this was no easy task. It's been about 8 years to bring this to market. So 4D LiDAR is adding the dimension of velocity. It's giving very long range performance to 500 meters, which becomes crucial for getting that 65 miles per hour capability on the highway. But also, we've had to put a lot of investments in putting everything on the chip. The type of LiDAR you talk about, you're absolutely right. Started with tens of thousands of dollars, built on fiber-based technology, built on maybe other type techniques that were not very easy to assemble. The cost of those typical time of flight LiDARs have come down now. But what we have done is we're providing this kind of performance at a level that actually is not really possible in the market today, all because of the fact that we've been able to put all the aspects of LiDAR on a chip. So this big spinny stuff has now come down to a silicon photonics. We have our own SoC, similar to what some of friends over at Mobileye have done on the processing side, to be able to actually process that data. And this allows us to bring the cost down of the technology in a way that can scale in commercial vehicles. We've publicly talked about initially was about $1,000. It's no longer tens of thousands. But more importantly, use that economies of scale with, even 10,000 type vehicles. We are having close to 100,000 LiDAR sensors that we have to scale. Use that economies then quickly to bring it to the passenger vehicle market, which brings the cost down even further into hundreds of dollars. And that's been kind of the strategy.
And what can you see at 500 meters?
We can see a number of things. So first of all, we can see objects such as vehicles. That is very crucial. But I think more importantly, we provide kind of the ability and the confidence for folks, including the major OEMs, for example, with Daimler and Torc, so they can differentiate what they need to do. If you have a time of flight sensor, let's say you get 3 points, it won't be at 500, let's say 250. But let's assume that it will be at 500, so we kind of get that 2x the range. You get 3 points. You don't know if that's noise. You don't know if that's a person. You don't know if that's 3 vehicles. That's a bird. You don't know what it is. All you can do is keep looking for the most part. Maybe there's other things you may want to do, but with FMCW, you have that velocity. If the 3 points have all the same velocity, you know that that's one object. If they're all coming towards you at 65 miles per hour, it's on the road. You can make a pretty good assumption that that's a vehicle you should be paying attention to. And you can do that at that instance. You don't have to keep waiting. That's the extra advantage of timing.
And that's why you need that range, because in the end it's all about planning. That you don't bring your vehicle in a dangerous situation. And for forecasting the future, you need that range. And then this combination of radar, of cameras, stereo cameras, telecameras, and this long range LiDARs, it's just amazing. Enabling this of 65 miles per hour.
Right.
Which we were, by the way, showing this last year on a closed course. And it was our first product release, so it was the first time that we were driving without a driver on a test track, lap, overlap, at top speed 65 miles per hour. So we unlocked it and did a product release. And that was only possible using the Aeva technology.
So a significant milestone in the closed course.
I mean, that for us, that was the big milestone last year. When driver out on a closed course, top speed 65 on fully production intent hardware
Right.
from the rubber to with all awarded with the final suppliers at target.
Okay.
Amazing.
Yeah.
So it
So
was a great year and even better things to come up.
yeah, Joanna, there's a lot of good, useful energy happening between the OEMs and automated driving system developers, and we're seeing it across the industry. Could you help the folks here understand once you have that kind of partnership with Torc in this case, what do you guys do on the OEM side? What is your role, and how do you sort of split that out with the developer?
So first of all, I think collaboration is really key in this whole industry, and we realized very early on not one entity can do it alone. And so it's been a great journey so far. But I think what's important is that everyone really understands their role in the development of it, in the release, but then also how we take it to market. The beauty of the relationship we have with Torc, for example, is that while we are independent companies, still working very closely together. So for us, for example, we emphasize really working closely with our customers. So we started, for example, Torc started piloting with customers already, even though the technology is not yet fully released, but we learn so much in the interaction with them. And I think that role in that joint learning, gathering that feedback, and then improving the product over time, that will continue even after the first launch in 2027. And gathering that feedback, implementing it, and you, for example, talked about cost. Our customers are TCO driven. That's really what counts. Every cent counts that we can save them in this, and safety driven as well. So that combination, working on that and continuing to bring the costs down, ensure safety at all times, that is a non-negotiable. And again, in this partnership, working closely with ultimately the users of this technology, because we're not just doing it because we like to invent and we're so smart. We like to do that for our customers, make them more successful. And I think that collaboration is working well.
So it's not enough just to be cool tech. Got to do more than that, right?
It's cool to be cool tech.
It's cool.
But you need a little bit more. We also want to make money, and we want to make the world a little bit better place with safer roads and enabling more freight movement.
Yeah, and I'm glad you spoke of the customers. Peter, let me ask you. Torc has done trials and whatever with various freight haulers. What have you learned from their experience with your platform?
Interesting enough, a lot of it's a thing that people solve the technology together with Daimler. For them, that's more or less a given. So the question here is much more about how does the operation of such a thing, like how does it fit in into the fleet management systems? How is the operations like? How is operations changing? How is maintenance changing? What does it mean for technicians like that?
Mm-hmm.
And I think maybe just to add to that, because we've been working together, both teams, on a customer journey pretty much end to end, and it's just fascinating all the touch points you have, and you have to be very clear who's doing what at what point in time, how you're going to triage an issue in the field. For example, you need to have fast response times. We need to make sure we have spare parts available. We have repair concepts in place. We know who can actually diagnose and fix the issue fast. So I think there's a lot of things that come after the initial design, development, and launch make this a viable product.
Yeah, I would also add, I guess from a supplier side, it's important that we have the ability to be near where both from a production standpoint, manufacturing locations are kind of aligned as closely as possible, so we can be efficient. But also, we have the ability to support, if need be, in the field or quickly, at our site within the United States. Also, that's actually.
And so, how does a freight hauler acquire their own Torc truck with Aeva inside, with Daimler as the wrapper Freightliner? How does that happen? Does you just go down to a truck dealership in the future?
In the very future, but I think at the beginning it is already a joint collaboration from the start.
Mm-hmm.
I think the sales process is changing a little bit in the sense of there's a lot of onboarding going on. Torc has to obviously evaluate the routes, and if they're approved within their ODD, we have to look at if this is really technology that's feasible and viable for a customer. That's not going to be for everyone. Not all the length of routes are going to be economically viable. So I think there's going to be a lot of consulting happening until the order is placed. But when that moment comes, it's a very simple process. The customer orders truck from Daimler Truck. They order the subscription from Torc, and then miraculously it will roll off the line and end up in their hub and then drive itself over the highway.
Yeah. Well,
So
we've
it's
got
kind of-
about 3 minutes left, and I want to ask each of you what do you see happening in your world and during this new year that we're a week into? And Peter, I'll start with you.
Yeah, on our end, it's pretty simple. We will put this truck that performed awesome on closed doors with driver out now on public roads in Texas and adding more and more features. So it's really driving in our target reach, Dallas, Laredo. And then building up, we just today announced that we have that we will open up our first hub in Dallas Fort Worth, signed the lease, also pulling out the operations out of our old hub. This will be the two main topics, and then of course working on scaling, on productionizing, and commercializing.
Right, and you're very much building up your new Texas operation. Maybe just say a quick word about that.
Yeah, if you run Dallas to Laredo, you want a hub at, let's say, both ends. Dallas is just a fantastic place. It's not only our route, but it would also connect by 40. And that's why we picked it. There's a lot of freight. It's very supportive from regulation. And there's great talent. And that's why we operations testing in Dallas. And then can also build, let's say, a model hub, small to big, in different versions, where you can also try out how does maintenance work, how does operations work, small scale, large scale, mid scale. It will be super exciting, especially also for our customers.
Great.
Therefore.
Yeah, great. So, Joanna, what do you see when you think of 2025?
Yeah, for us, 2025 is going to be the year where we really move from the hardware side to really production-ready hardware. So we're kind of pre-production, we call it C-sample. A couple of the components are already D-sample status, which is like the production-ready maturity. So this can be built on the line. So this is the year we will be ready for start of production from the vehicle platform. That's the hardware side. And then from the software validation and release, really making this autonomous ready platform, getting this autonomous ready platform public road release for driverless. So our goal is that the truck is ready for the driver to be removed, so to speak, when our partners are ready. And this is the year.
Sure. And, for anybody that's been in the business for a while, like myself, you're speaking, a very logical way about things that are happening. And I want to just jump up and down and go crazy because I've been in this space for, since the first automated truck discussions were happening. It's just remarkable.
We jump up and down behind.
Well, okay, right.
Not in front of.
We'll have our own little session for jumping up and down. So, Sarush, I'll give you the last word and speak about Aeva, but also maybe how you see the role of Lidar in autonomy generally. I think that'll be useful.
Yeah, I want to maybe just answer first on what we're planning also. Obviously, we need to be ready on our side, on the production side. 25 is a year of scaling production for us. We're setting up our final sample, which is production ready, first automotive grade Lidar we're going to scale with. What this looks like for us is, if you think about it from a content per vehicle, thousands of trucks equates tens of thousands of sensors. 10,000 of trucks equals 100,000 sensors.
Wow.
We need to go. So this year is the year that our team is setting up the operations, working very closely with Daimler and Torc to make sure that they're also supported for the production release on the road. And then next year, we're going to be really scaling that up. So that's kind of where our focus is just, pedal to the metal and go at this point.
Yeah.
I think to your other question about what I see about the kind of general space for Lidar and the future, to be honest, I think this is one of the most exciting times that we've seen in the industry. I would say not just because of the fact that we are going to production, but we have seen now OEMs, one after another actually starting to deploy. It's taken a lot of years. Timelines got pushed out.
Yep.
I think now the kind of some of the first launches happening. The scaling is actually going to take shape as we look between now and 26, 27 for the commercial vehicle space. We see that across kind of the space, small, but for passenger vehicles is really where the next generation, the year or so after following that. So I think that scale going from tens of thousands to multiple hundreds of thousands is really happening now. And for us specifically, we are also very excited by the by the prospects and the opportunities we see in industrial manufacturing, factory automation, all of which is possible because we invested significantly in making sure that commercial vehicles and others is possible to scale, and it's automotive grade, meeting those strict standards of quality.
Oh, excellent way to end the discussion. So, Peter, Joanna, Sarush, thank you for all of your comments and a great conversation. Thank you.
Thanks, John.
Thank you.
Thank you.